So hey guys, Jeff here. Today I want to talk about the luminaries, the sun, the moon, and the stars, and how they rotate around in the firmament above us. I've gone over the sun in the past, so you might know a little bit about this subject. The sun goes around in a circle, and it takes 24 hours for the sun to circle the flat earth in one day. And the sun's circles get bigger and smaller depending on the time of the year. In June, the sun is circling over the Tropic of Cancer. So it's got a much tighter circle. In December, the sun is circling over the Tropic of Capricorn, so it's got a much bigger circle. And at the equinoxes, the sun is circling over the equator. Okay, equinox, equator. Now the moon also circles above the flat earth, but the moon is slightly slower than the sun. The moon takes 24 hours and 50 minutes to circle the flat earth. That's what's called a lunar day. It's slightly slower than the sun. So where the sun takes 24 hours to make one 360-degree circle, which is 15 degrees an hour, the moon takes 24 hours and 50 minutes to make one 360-degree circle, which equates to only 14.5 degrees per hour. So the moon, because it's slightly slower, it loses a half a degree on the sun per hour. So this half a degree per hour equals 12 degrees per day. So as the sun and the moon circle above in the firmament, the moon loses 12 degrees per day on the sun. And this 12-degree loss causes the lunar phases. So as you see here in this little animation, we've got the sun and the moon circling above, 1 hour at a time. And by the time the sun gets back to its original position at 12 noon, after one full day has gone by, the moon has lost 12 degrees on the sun. And this happens every day. And this loss of 12 degrees per day is what's going to cause the phases of the moon. So if you were to look up at the sky on day 1 at midnight in New Jersey, the moon would be here. And if you were to look up at the sky at the exact same time on day 2, the moon would be here. It's lost 12 degrees. It's 12 degrees further to the east. And if you were to look up at the sky at midnight on day 3, the moon would be 12 degrees further, and 12 degrees further, and so on and so forth. The moon loses 12 degrees per day, and this causes the phases of the moon. And I did my best to try to animate this for you so you could see it and understand it better. Now the stars are slightly different. There's something known as a sidereal day, which is slightly shorter than a solar day. A solar day is a true 24 hours. A sidereal day or a stellar day is what's slightly shorter by 4 minutes. A stellar day is only 23 hours and 56 minutes. So because it's 4 minutes faster than a regular day, this 4 minutes equates to 1 degree. So the stars all rotate around Polaris every single day, but because they're slightly faster than the sun, it gains 1 degree per day. And this causes the stars to shift 1 degree per day roughly, or roughly 7 degrees per week. So if you were to look up at the sky at the same time every day, they're going to be slightly different because they're shifting 1 degree every day. So here I've made a little animation of the Big Dipper and Polaris. I'm not going to include all the rest of the stars in this because, I'm not a computer whiz, but I can do the Big Dipper and Polaris. And every day it circles around Polaris. Polaris never moves. The North Star never moves. I know in my little animation it's bouncing around just a little bit here, but it's supposed to be constant. It never moves. It's a guide. So 1 rotation equals 1 stellar day. Now because it gains 1 degree per day, if you were to look up at the sky at week 1, you're going to see this. And week 2, if you were to look up at the sky at the same time, it's going to be shifted 7 degrees. And week 3, it's going to be shifted another 7 degrees roughly, and week 4, and week 5. And throughout the year, the constellations will constantly shift because they shift 1 degree a day roughly. And we have 365 days a year. So it's slightly less than 1 degree, but you get the point. This is how the constellations shift throughout the year. And this shift causes the constellations to be in a different spot throughout the year. And when this happens, you get fall, winter, spring, and summer. The 4 seasons. This symbol is an ancient symbol. You might know it as the swastika, but what it really means is the 4 seasons, because if you were to look at the Big Dipper throughout the year, this is what it's going to look like. Constantly pointing to the North Star, which never moves. So you got your spring, summer, fall, and winter. Unbelievable stuff. And it never stops. It just rotates around.